it's May 2023, question number 4. Let's get started. Hydra are small animals that live in water. It's a hydra. They have a cylindrical body. The drawing shows a hydra. Okay. This hydra has a body length of 1.8 millimeter and a diameter of 1 millimeter, which is the magnification of this drawing. Okay. There's a formula of finding out magnification, that is, let me just write the formula first, that is I equals to AM, where it's a formula where I means the image length, A is the actual length, and M is the magnification. Okay, so we will use this formula to find the answer. Okay, you need to remember it. I equals to AM, where I stands for image size, A for actual size, and M for the magnification. Okay, so here it says this hydra has a body length of 1.8 millimeter body length, so it is the actual length. Okay, this is the actual length. Okay, 1.8 millimeter and a diameter of 1 millimeter. So we actually don't need it right now. We need to find the image length, so we must have a ruler in our exam. We will find the length of this hydra using the ruler, and then we will put the values in this formula and we will figure out the answer, which is okay, just say I equals to AM. Here the 1.8 millimeter is the actual length, and I is for the image length. Okay, so image length is 48 millimeter, and the answer is 2.68 to the power into 10 to the power 1. So D. Which is the surface area in millimeter square of this hydra? Use the formula surface area equals to 2 pi RL. Okay, 2 pi RL. Here 2 is 2, pi is pi, R is the half of the diameter, which is 0.5, and the length, what is the length? The length is 1.8. okay, we will put it in the formula and we will figure the answer out. Okay, simple. 3 number. Another hydra has a surface area of 2.3 pi millimeter square, a body length of 1.8 millimeter, and a diameter of 1.2 millimeter. Calculate the surface area of volume ratio of this hydra. Use the formula volume equals to pi r square L. So here the volume equals to pi r square L. Okay, this is the formula, and we know the surface area, it is 2.3. so we will figure out the surface area to volume ratio of the hydra. So for the volume, it's pi, r is 0.5 square, which is 1, and the length is 1.8. then we will just calculate the volume to the ratio, the volume ratio of this surface area to volume ratio of this hydra. Okay, as simple as that. Then 4b, a hydra has a hollow body that is made up of 2 layers of cells. Explain how this hydra is adapted for gas exchange. Okay, so actually during this type of question, we need to just understand the question first to write the answer, because the answers are partially written in the question. Okay, So a hydra has a hollow body. It says it has a hollow body that is made up of two layers of cell. Like the cell is thick. Okay. Explain how hydra is adapted for gas exchange. So as there are only two layers of cell, so the cell is as thick, right? So short diffusion distance, right, for gases to exchange faster, and we just calculate the surface area to volume ratio, right? Large surface area to volume ratio, which large surface area to volume ratio are an indicates of faster gas exchange. Okay, then they have tentacles in their body, it shows in the figure, so it helps them to move around the water and gain, and it maintains the concentration of oxygen in the water, right? And of course oxygen is always dissolved in the water, which is needed for them. So here is the answer. Oxygen is present in the water, large surface area to volume ratio, which increases the diffusion rate. Short diffusion distance, as the body is made up of two layers of cell. Tentacles slash body move the body around the water to maintain the concentration, to maintain the oxygen concentration. Okay.